Hi there. In today's video, we'll be looking at parameters of trigonometric functions, and we are looking at the effect of k. And k is the coefficient of x. So k, as you can see, is over there inside our function. So the effect of k is that it is going to cause a horizontal stretch. So horizontal stretch. Now what this means is if a standard graph, so let's use sine, if it looks something like this, if it's then being stretched, it's either going to look something like that or it will be more stretched out. So it's either it's going to look compressed or extended and stretched out. So let's draw the graphs so that you can see the effect of k when it is a whole number versus when it is a fraction. So example. In our example, we'll be using the graph of sine. So y is equal to sine 2x. Here you can see that our k, let's use a different color, orange is fine. Our k is equal to 2, so that's the coefficient of x. And because it is a whole number, we expect to see the graph to be sort of compressed. So whole numbers cause compression. And we're going to draw the graph so that you can see what this compression will look like. Okay, so let's draw the standard graph of sine x. Whenever we are looking at different parameters, we always want to start with the standard graph. Okay, so this is y. And this will be my x-axis. Over here, we've got 0, somewhere there, 360 degrees. In the middle, we've got 180. Here we've got 90 degrees. And here we've got 270 degrees. Our maximum is 1 and our minimum is -1. So the standard graph of sine, let's use this magenta. It starts at 0 and then at 90 degrees it hits its maximum. At 180 it's back at 0. At 270 it hits its minimum, and at 360 it's back at 0. So it looks something like that. Like that. So this is the normal graph of sine x without any change in parameters. Okay, so now let's draw the graph of sine 2x. So the thing about k is that it also affects the period. So let's add it here. Let's remove those squiggles. And let's say that it causes horizontal stretch and changes the period. So for you to be able to visualize that compression or stretch, you first need to determine what is your new period, because it's going to change. So there's a small equation and its period is equal to 360 degrees divided by k. And we use 360 because the graph of sine and the graph of cos, they have a period of 360 degrees. So this is for the graphs of sine and cosine, which is cos. And then for tan, you use a slightly different degree equation. Its period is 180 degrees divided by k, and this is for the graph of tan. And this is because tan has a period of 180 degrees. So we are currently looking at the graph of sine. So let's get the period of this new graph. So period will be equal to 360 degrees, and our k is equal to 2, so we're going to substitute that. 360 degrees divided by 2 leaves you with 180 degrees. So what this means is the original sine graph takes 360 degrees to complete a period. However, it has now been shrunk to 180 degrees. And what we can see here happening in this equation is that we are basically dividing our x coordinates by this k value. So what is going to happen is that coming here, so let's pick a green, we're going to basically divide each coordinate by 2 so that we can get the new graph that fits within 180 degrees. That means 0 remains at 0, but 90, when you divide 90 by 2, you get 45. So this maximum over here is going to shift to 45, which is somewhere here. So that's 45 degrees. So the new maximum is there. And then another critical point was 180. So when you divide that by 2, you get 90. So that means this critical point has now shifted here. And then the other critical point was 270. When you divide that, you get 135, and it's somewhere over here. And that the y value is at -1, meaning that our point is now here. And then 360 was at 0, so divide that by 2, you now are at 180, and y is still 0. So joining all these coordinates, they now look like this. So as you can see, like we said, whole numbers for k cause compression, and we can see that our graph has now been compressed. It used to take 360 degrees to complete a period, so to have a complete wave of sine, but now it only takes 180 degrees because our k value is a whole number of 2. So we had to then divide each x coordinate by 2. So this is one example of the effect of k, which changes the period. Now let's look at an example when k is not a whole number, but a fraction. Example. Let's now use y is equal to sine a half x. Yeah, let me put brackets there. So now k is a half. That means we now need to calculate a new period. So the period for sine is 360 degrees divided by k. Our k is a half. And now you end up with a total of 720 degrees. So the new period is 720 degrees. So what we can see from this is that when k is a fraction, it causes like a horizontal stretch. So think of it as a spring, and you're like pulling it, and those waves are now being stretched out. So let's write that. So we can say fractions cause horizontal stretch. Okay, so let's start with the standard graph of sine. It will be much easier for us because we have one at the top. So work smart, not hard. So let's just duplicate this and then shift it down. And then we'll extend this graph. Okay, let's erase the green. Okay, some of the green is hard to get rid of, but I've tried to get rid of most of it. Okay, and now we need to extend our line on the x-axis to accommodate the 720 degrees. I think this should be enough. Okay, so this was 360 degrees. Okay, so adding 90 to that. So somewhere here we should end up with 720 degrees. All right, so first we want to add the first, let me make my markings, and then I just need to add the values. All right, so 360 plus 90 is 450. And then we add another 90, that's 540. And then we add another 90, that's 630. And then 720. Okay, so now we just need to add the coordinates for the new graph of sine a half x. All right. I think let's use a different color. A blue should be fine. So we said that to get the new coordinates, you take your critical points and you divide them by your k value. We are dividing by a half, which is essentially the same as multiplying by 2. So 0 multiplied by 2 remains at 0. However, this coordinate over here, which was at 90, we multiply 90 by 2, that's 180, meaning that the maximum has now shifted to somewhere over there. I can move this to be out of the way. So 90 is now here. It has moved. That's the new maximum. The next critical point is at 180 degrees, which is 0. So multiplied by 2, that's 360. So y is equal to 0 at 360. The next critical point is here at 270. You multiply that by 2, you get 540. So that's where our minimum is, which is somewhere over here. And then lastly, 360 multiplied by 2, 720. So at 0, it's over there. Now I just need to join my points. So it's like that. And then it comes down like that. Connects there, goes up like that. Now this blue one is the graph of sine a half x. And as you can see, like what we said earlier, when k is a fraction, it causes a horizontal stretch. So your graph has sort of been stretched out like a spring. So these are the effects of k and how it affects your period. So before Sine x used to take 360 degrees to get a complete wave, but now it takes 720 degrees to get a complete sine wave. So these are the two different effects of k on the period. So whether it is a whole number or a fraction, that will tell you whether the sine graph will be compressed or if it will be stretched out. Okay, that's all from me.